at the Empirical Analysis Center EAC in Rawal City. Today we are going to introduce to you the last research carried out by our department of first level of data analysis. This department analyzes data obtained in initial tests on the ecosystem, that is to say, without being processed by a second level statistical protocol. The researches of this department have got a reliability of 95.53%. It is not much compared to the 98.7% that our center usually offers, although it is quite clear that reliability is reduced a little. The operativity of the processes allows us to have data on the table in a very short time, in connection with the evolution of the ecosystem. Other more rigorous procedures offer results within very extensive periods, which result little operative if we compare them with process evolution. In today's program, we are going to talk about the contribution to the greenhouse effect of the most usual combustibles. Professor Devnath, what does the project involve?
Well, we have prepared a rigorous evaluation of the rates of contribution to the greenhouse effect of some combustible gases. We have measured the enthalpies of standard formation of combustibles and of the products that result from combustion reactions. By means of a subsequent process of calculation, we have evaluated the enthalpy of subgestion of the combustibles.
What connection do the obtained values have with the greenhouse effect?
Once we obtain the enthalpies of combustion in connection with the amount of dioxide emitted, we evaluate a contribution rate to the greenhouse effect by means of calculating the grams of dioxide emitted per kilojoules of heat obtained. This rate is directly related to the contribution to the greenhouse effect of each combustibles.
Contribution to the greenhouse effect of ethane. The combustion reaction of 1 mole of ethane produces 2 moles of dioxide. The enthalpy of formation of ethane, the enthalpy of formation of the dioxide and of residual water vapor. Combining these reactions, we obtain the ethane combustion enthalpy. For ethane, the grams of dioxide emitted per kilojoules of energy obtained are 0.0564 grams kilojoules. We define this value as the contribution rate to the greenhouse effect of ethane. Contribution to the greenhouse effect of butane. The combustion reaction of 1 mole of butane produces 4 moles of dioxide. The enthalpy of formation of butane, the enthalpy of formation of the dioxide and of residual water vapor. Combining this reaction, we obtain the butane combustion enthalpy. Taking into account that the combustion of 1 mole of butane produces 2,876.5 kilojoules mole. For butane, the grams of dioxide emitted per kilojoules of energy obtained are 0.0612 grams kilojoules. This value will be the contribution rate to the greenhouse effect of butane. Contribution to the greenhouse effect of octane, known as the basic constituent of petrol. The combustion reaction of 1 mole of octane produces 8 moles of dioxide. The enthalpy of formation of octane, the enthalpy of formation of the dioxide and of residual water vapor. Combining these reactions, we obtain the octane combustion enthalpy. For octane, the grams of dioxide emitted per kilojoules of energy obtained are 0.0643 grams kilojoules. We define this value as the contribution rate to the greenhouse effect of octane. Contribution to the greenhouse effect of ethanol. The combustion reaction of 1 mole of ethanol produces 2 moles of dioxide. The enthalpy of formation of ethanol, the enthalpy of formation of the dioxide and of residual water vapor. Combining these reactions, we obtain the ethanol combustion enthalpy. Taking into account that the combustion of 1 mole of ethanol, for ethanol, the grams of dioxide emitted per kilojoules of energy obtained are 0.0644 grams kilojoules. We define this value as the contribution rate to the greenhouse effect of methanol.
In short, we can see that in the world of conventional combustibles, that the combustibles with the greatest energy performance are the most polluting. The energy management should evaluate a compromise between performance and polluting capacity. Traditionally, among the combustible fossils, and it has been considered that propane may represent a responsible balance. Nevertheless, research goes on waiting for more sustainable solution.
Thanks, Professor Devnath, for being with us.
It's been a pleasure.
Well, that's all for today. We will find you in our next program, Dream Investigation. Thanks for being with us.